Alright, today's lesson is 6.5, and our purpose statement is to explain and describe the steps to identifying the roots of a polynomial using the rational root theorem. And we have some vocab for today: the rational root theorem, the irrational root theorem, and multiplicity. So remember the roots. The roots are the same as the zeros, except it includes any imaginary solutions that there might be. So, we've used solutions, roots, zeros. When we use roots, it just means we're going to find all of them, whether they're real or imaginary. The first thing I'm going to define is multiplicity. And multiplicity, if you remember when we talked about polynomials to start with, that degree or the highest exponent is going to tell us how many solutions we have. So if it's a degree 5, we're going to have 5 solutions. If it's degree 9, we're going to have 9 solutions. But sometimes you have multiplicity, which means something occurs more than once. So multiplicity is when a root occurs more than once, and when a polynomial has an even multiplicity, so like let's say the answer 5 occurs 4 times, then the graph will touch the x-axis but not cross it. When the polynomial has an odd multiplicity, let's say it has 3 2's, then the graph will bend as it crosses the x-axis. Most of our things so far we've had, if we just take a quadratic and we graph a quadratic, it would come down and that line would go like this, and it would cross twice. And 1 0 would be here, and 1 0 or root would be there. So what they're saying is, if the graph comes up and just touches, then it's going to have an even multiplicity. Whereas if it comes up and as it crosses, it curves, it's going to have an odd multiplicity. So I've got an example here for us. And if we type that into the graphing calculator, x to the 5th minus 5x to the 4th plus minus 5x to the 3rd plus 45x squared minus 108 equals 0. So I just graph that in as y equals, and then I graph that. You can see that here it touches at -2, so that means I have an even multiplicity of -2, and it bends as it crosses at 3, so I have an odd multiplicity of 3. So that's all that means on multiplicity, that sometimes you can have a graph occur where it crosses and just comes down, then it's an even multiplicity, and where it crosses multiple times, you have an odd multiplicity. So that's not real important. It's just to understand that sometimes our answers can occur more than once. So to find the roots, the first thing I'd like you to do whenever you try and find the roots is to try and factor. Because if we can factor it, a lot of times we can reduce our work. And so when we go to factor this, the first thing we always check for is the greatest common factor. And so in this case, 3 goes into all of these. And also x to the 3rd goes into all of them. And so remember, I say, what do I have to multiply this by to get back to this? Well, 3 to get to 3 would be 1. X to the 3rd to get to x to the 5th would be x squared. And 3 to get to 18 would be 6. And x to the 3rd to get to x to the 4th would be x. And 3 to get to 27 would be 9. And x to the 3rd to get to x to the 3rd would be nothing. Okay, just 1. So we've gotten it to here. Now, from here, we can factor this. Now, if we recognize that this is a perfect square, it makes it really easy. We don't have to do the x method. That just factors into x plus 3 and x plus 3. And we still have this 3x to the 3rd. Once I get to an x squared, we can use any of our old methods. We can use the quadratic formula. We can factor it. I could have used the x method on this and said 9 times 1 is 9. And 6, and then that would be 3 and 3, which would give me the x plus 3 and x plus 3. We can use any of our ways to find the zeros there that we want. So now, in this case, we've got 3x cubed So what makes 3x cubed equal to 0? Well, I could go through the steps and divide by 3 and get 0, and then x cubed equals 0. And what to the third power gives you 0 would be 0. Now really what I have here though is because it's x to the third, I really have 3 zeros. So this would have, 0 would have a multiplicity of 3 because it's going to occur 3 times. And we have 2, remember, again you can set this equal to 0 and solve, subtract 3 and get x equals -3. Or you can use the shortcut which says the opposite of this divided by the number in front. So opposite of 3 is -3 divided by 1 is -3. But that occurs twice. So -3 has a multiplicity of 2. It occurs twice. Now remember, we said our highest power is 5, so that means we're going to have 5 roots. In this case, we only have 2, but that's because 0 occurs 3 times and -3 occurs twice to give me my 5 roots. So you always want to try and factor. Because if we can factor, a lot of times it either makes the problem easier or it saves a lot of time that we can just find the zeros or roots by factoring. So, example number 1, this is what I would like you to try on your own, so on your paper. So go ahead and try that. You can pause this and then come back and check it. So to do this, the first thing we should do is set it equal to 0, add 36. There is no greatest common factor. Now this is going to be a little bit different for a lot of you. We have to look at this. We're used to factoring x squared, but as long as the power in the middle is half of this, we can go ahead and try our x method. So I'm going to go ahead and do the same thing. 36 times 1 is 36. -13. So the factors of 36 that add up to -13 are -9 and -4. I don't need to do the x method. The only thing we have to do on this is because this is x to the 4th, we have to add, normally you just add x's with these, but now we're going to add an x squared. So we get x squared minus 9 and x squared minus 4. Now, here it again would be nice to be able to recognize the shortcut, and this is the difference of 2 squares. If you can't recognize that, you can always do the x method. You'll still get the same answers, but this factors into x plus 3 and x minus 3, and x squared minus 4 factors into x plus 2 and x minus 2. And so our solutions are -3, +3, -2, and +2. Now again, if you don't recognize that these are the difference of 2 squares, we can just use the x method. This would be -9 and 0, so 3 and -3, which gives us the x plus 3 and x minus 3. And -4 and 0, so that would be 2 and -2, which gives us the x plus 2 and the x minus 2. So it's nice to be able to recognize the shortcuts. It saves some time, but you don't need to. You can always go through and do the x method. So, that's if we can factor. A lot of the ones you're not going to be able to factor. Or you can factor it part way and not all the way to get all the zeros. So if you can't factor, you're going to use what's called the rational root theorem. So if you can't factor, or if factoring doesn't give you all the solutions, we're going to use the rational root theorem. And the rational root theorem says, if the polynomial p of x has integer coefficients, then every rational root, so this would only be the real numbers and only the rational numbers. So irrational numbers like square root of 5 or imaginary solutions or complex solutions like plus or minus 5i, those won't show up in this, but all the rational roots of the polynomial equation p of x equals 0 can be written in the form of plus or minus p divided by q, where p is a factor of the constant term and q is the factor of the leading coefficient. So that's a lot of terminology, but let's break it down. So if, as an example, we have a polynomial that starts at 3x to the 5th, and it's written in standard form, so this is the highest power, and it ends up at 8, all right? So what they're telling us, we know because it's x to the 5th, there's going to be 5 roots. Now those could be rational roots, whole numbers or fractions, real numbers. They could be irrational solutions like the square root of 3, or they could be imaginary or complex solutions like plus or minus the square root of 5i. But the rational roots, of the rational roots that exist, we're going to know that the p, this is p, okay, our constant term, and our leading coefficient, remember, is the coefficient of the term with the highest degree, so that's 3. So my possible rational zeros have to be the factors of 8. So what are the factors of 8? They're 1, 2, 4, and 8. And then that's our p. And then our q is the factors of 3, which are 1 and 3. So our possibilities are plus or minus. Now, I will let you know the book will put all the positive and then all the negative. I just write them together. So we're going to take the factors of 8, which are 1, and we have to put them over the factors of 3. So I'm just going to put them all over 1 first. So it could be plus or minus 1, because 1 over 1 is 1. And then we put 2 over 1, which would be 2. And then 4 over 1, which would be 4. And 8 over 1, which would be 8. And then we're going to put them all over 3. So 1 over 3 would be 1/3. And then 2 over 3 would be 2/3. 4 over 3 would be 4/3. And 8 over 3 would be 8/3. So we've come up with 8 possible solutions. Again, these are only the real solutions. And it gives us 8 numbers to try in the method that we're going to use to find these. Instead of just an infinite number where we can try everything, it just gives us 8 numbers to try. So we know that our real numbers have to be one of these 8. So now let's take another example. Let's take this one. Well, the first thing I'd want to do, so let's look at this example. First thing I'd want to do is put it in standard form. So I'm going to go 3x to the 4th. I'm going to move this minus the 23x to the 3rd to the side by subtracting it. So we've got it in standard form. So we know there's going to be 4 solutions because this is degree 4. And our possible solutions, again, you should always check for greatest common factor, which this doesn't have. So our possible solutions our p in this case is 6. And so the factors of 6 are 1, 2, 3, and 6. And our factors of q, our leading coefficient is 3. So the factors of it are 1 and 3. So our possibilities of p over q, so remember we're going to take all of these and put them over 1. So it's plus or minus 1, 2, 3, and 6, because when you put them over 1, it doesn't change them. And now we put them over 3. So we get 1/3, 2/3. Now if we did 3 over 3, 3 over 3 would be 1. Well, we already have 1, so we don't need to write that again. And 6 over 3 is 2, so we already have that. We don't need to write that again. So that gives us 6 possible numbers to try. And what we're going to do is we're going to go back, because we remember when we did synthetic division, if the remainder was 0, we knew that it was a factor of the polynomial. So once we've got that, there's some other things we can do to shorten up the process on the possible numbers to try. And that is, when you do to find the zeros, the number of possible positive zeros is found by finding the number of sign changes in p of x and then reducing that number by 2 down to 1 or 0. Now I know this seems complicated when you just read it, but it's really not. So let's go through and use this problem. All we have to do is count the sign changes. And that is, if it's from goes from positive to negative, or negative to positive. So you just start with whatever the first term is. If it's positive, it's positive. It's negative, negative. It's no change. It's just wherever we start. So this started positive, and then it went to negative. So that would be one sign change. Then it went to positive, so that would be a second sign change. And then it stays positive the rest of the way. So we have two sign changes. And then we go down by reducing that number by 2. So we go down by 2's until we get to 1 or 0. So in this case, it would be 2 or 0. What this tells you is the number of possible positive solutions. So there's either 2 positive solutions or there's no positive solutions. So let's say there were 5 sign changes. If there were 5 sign changes, then we go down by 2's, 3, 1, and it'd be 5, 3, or 1. What this helps us is where to start, how many of the possibilities we have that are positive, so it tells you maybe what numbers to start with. So that's the number of possible positive zeros. To find the number of possible negative zeros, and this causes a little bit more problems for people, it says the number of possible negative zeros is found by finding the number of sign changes in p of negative x, and then reducing that number by 2 again until we get to 1 or 0. Now here's where people make mistakes when they do this. So now what they're telling you to do, it says p of negative x. So that means if we go back to this, every time we come to x, we're going to replace it with negative x. Okay? Well, if I was to simplify this, negative x to the 4th, that would become 3 x to the 4th, because an even number of negative signs is positive. Then here I would have 3 negative signs, and so this would become negative 23 negative x to the 3rd. But a negative times a negative is a positive, so that would become 23x to the 3rd. And then negative x squared would become positive x squared, because 2 negatives is a positive. And then we have a negative x, so that would become negative 27x, because we get 27 times a negative 1 plus 6. And again, we count the sign changes. So it starts positive, and then it stays positive, and then it stays positive, and here it goes to negative. So that's one sign change. And then it goes back to positive. So we have 2 sign changes. And then we just go down by 2 until we get to 0 or 1. And so this tells us there could be 2 positive and no negative positive solutions, or we could have 2 negative solutions or no negative solutions. So it just gives you an idea where I always start with one that has an odd, because that means there should be one that occurs. In this case, you're just going to have to pick a number to try. So, the other thing I do, I never write this out. I just go here and I look at the problem and I say, okay, we have 4 negatives, that's positive. And you just count your negative signs. Here I have 3, but I have 1 in front, so I have a total of 4 negatives, and again, an even number is positive. Here I have 2 negative signs, so that's going to be positive. Here I have 1, that's an odd number, so that's negative, and the constant all remains the same. And now I just go through. Positive, 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 changed once, changed twice, so I get to 2, 0. You don't need to write this out. You can always do it just from the original. Just say, okay, I'm going to put a negative in here, 4 negatives, it's positive. Let's go right to this one. Well, 3 negatives plus 1 is 4, so that's positive. 2 is positive, 1 is negative, the constant stays the same. And so you can just do it up above the problem. But it's totally up to you. If you like to put in the negative x, that's fine. So now, we've got this problem. Let's rewrite it right here. 3x to the fourth minus 23x to the third plus 19x squared plus 27x plus 6 equals 0. And now we're going to go through and find these zeros. So we're going to use synthetic substitution with the possible answers. Remember, our possible answers are, let's rewrite those, plus or minus 1, 2, 3, 6, 1/3, and 2/3. So we're going to use synthetic substitution with the possible answers to find the zeros of p of x and continue until p of x is down to a degree 2 polynomial. So remember, degree 2 would be something squared. The reason is, once we get to a squared, we can then use the quadratic formula is probably the easiest thing to do, or we can factor to find the last two roots of the problem. Because remember, we're only going to find the real solutions here. We're not going to find the irrational solutions, and we're not going to find the complex solutions by doing this. So, remember synthetic substitution. We have to choose one of these numbers to try, and then our coefficients are going to be 3, negative 23, 19, 27, and 6. Okay? So we have to pick one of these. And you just have to make an educated guess. You can pick any one of them to start with. I kind of like to pick one in the middle so I can kind of look at it. But here's some things we know. I like to keep a chart of my solutions so I can kind of compare and see where I'm at. We always know that when we plug in 0, we're going to get our constant value. So when I plug in 0, I know I'm going to be at 6. What we don't know is, what's this graph doing? Is the graph going up there? Is it coming down there? So we just need to plug in a number to try. And since we've got these 6 numbers, I would probably choose 1 or 2 because it's kind of in the middle. So again, we can try positive or negative. We just have to make a guess. I'm going to try 1 because 1's easy. So remember our synthetic division. We bring down the number. 1 times 3 is 3. We add negative 20. Add, or multiply 1 times negative 20 is negative 20. Add negative 1. Multiply negative 1, 26. 1 times 26 is 26, 32. Now you can tell we didn't get 1 is not a 0. But what we do know now is 1, we're at 32. And what this tells us is either the graph has crossed twice or it hasn't crossed at all yet. So, nice thing about Smartboard, we can just erase it here. You're going to have to just try this again. So let's try 2. See what 2 gives us. When I plug in 2, 3, 2 times 3 is 6. So we get negative 17. 2 times negative 17 is a negative 34. That gives us a negative 15. 2 times negative 15 is negative 30. That gives us negative 3. And 2 times the negative 3 is a negative 6. And so we get 0. So now that we have 2 as an answer, here is what's really important. Once you get a 0, we're no longer going to try with these coefficients. You could, but our whole purpose is to get down to where we only have 3 numbers here, because then I can use the quadratic formula or factoring or completing the square to find the other 2 zeros or roots. So we're going to go ahead. We know there could be 2 positive solutions, so we can try other numbers. But what I'm going to do is, let's go ahead and leave that 2 there. I'm going to go from here now. So we could try 3. And if I try 3, 3 comes down. 3 times 3 is 9. We get -8. 3 times -8 is a -24. We get a -39. Times 3 would be a -117. And so we get -120. It's not a 0, so 3 doesn't work. I'm going to go ahead now and try some negative numbers. We found 1. It could be that one of those fractions is a possibility, but remember, it could be an irrational number, and that won't show up in our solutions. So let's go negative. We know we're at 0, we're at 6. This was going up, so it's probably going down. So let's just try -1. And if I plug in -1, we get 3, -3, -20, 20, 5, -5, -8. So at 1, we're at -8. Now, what that tells us, I know now that, again, if you think about your graph, at 0 we're at 6 and at 1 we're at -8. It has crossed the x-axis now between 0 and 1. So I know that I want to try one of our possibilities between 0 and -1. And that would be either -1/3 or -2/3. And since it's closer to the x-axis at 0 than it is at -1, I'm going to try -1/3. So we bring down the 3. 3 goes into 3 once. We get a -1, -18. 3 goes into -18 6 times. And 6 times 1 is 6, and we have 2 negatives, so that's a positive. That gives us a -9. And 3 goes into 9 3 times. 3 times 1 is 3. And 2 negatives is a positive. And so we get 0 as our answer. So now we have another answer is -1/3. Now here's what's important. Remember when we did synthetic division? This is our remainder, constant first power, second power. So this is 3x squared minus 18x minus 9. And so now we can use all our tools available we have to find a quadratic. So you could use the quadratic formula. I always try and factor if possible. The one thing, either way, you can pull a 3 out, and you get x squared minus 6x minus 3. And that's not factorable. We could go through if you did the x method, -3. Remember, there's no variable with this, so we don't have to worry about that 3 anymore. -3 times 1 is -3 and -6, and there's no factors that multiply together to give -3 and add up to give you -6. So we just use the quadratic formula. So we have, remember the quadratic formula, -b plus or minus b squared minus 4ac. And remember, some of you have been forgetting this. It's all over 2a. So I'm going to plug that in. So we get 6 plus or minus the square root of 6 squared, so 36, minus 4 times 1 times the -3, all over 2 times 1 is 2. So we have a -4 and -3 times 1 would be 12, and 2 negatives is a positive. So we add 12 and we get 6 plus or minus the square root of 36 plus 12 is 48, all over 2. And then again, you have to remember, always try and reduce. So with 48, I can break that into 16 times 3. And so I get 6 plus or minus the square root of 16 is 4. Square root of 3 over 2. And then since 2 goes into everything, I get, I'm going to go this way, 2 goes into 6 3 times, plus or minus 2 square root of 3. So our solutions, if we go back up here, our solutions are 2, negative 1/3, and then 3 plus or minus 2 square root of 3. So you can see we said we were going to have 2 positive answers and 2 negative answers. Well, we have 1 positive here and 1 negative. 3 plus 2 square root of 3 is going to give me another positive solution, and 3 minus 2 square root of 3 is going to give me another negative solution. So we have our 4 solutions, and so we've finished the problem. So as you can see, it's quite a process to go through. You have to be careful. The irrational root theorem is the other thing we said we'd define. If the polynomial p of x has rational coefficients of a plus b squared root of c, is a root of p of x equals 0, where a and b is rational, and c is irrational, then a minus b squared root of c is also a root. So, a lot of words. Biggest thing is, it's because we get plus or minus the square root. And so because we have 3 plus 2 square root of 3 and 3, remember, this gives me 3 plus 2 square root of 3 as one answer. And all this is saying is you also have, it's 3 minus 2 square root of 3. But you can just write it this way as a plus or minus when you write your solutions. So, it is a long process. You have to be careful as you go. The assignment is page 442, numbers 11 to 19 all, 24 to 26 all, and 29 to 34 all for your assignment. But we're going to do 11 to 14 as a class, and so I'm going to go through these on this for those of you that aren't in class today, so that you have that. To kind of take you through, because you just need practice on these. Follow your steps, have your notes out as you go through, and take your time. So we're going to start with 11. So x cubed plus 6x squared minus 5x minus 30 equals 0. Okay? So the first thing we always want to do is to check it and see if we can factor it. There is no greatest common factor, so we can't do that. But if you go to your notes from factoring, remember if it's more than 3 terms, we want to group that. And so we can just try this. It will work sometimes, other times it won't. So we get x cubed plus 6x squared in one group, and minus 5x minus 30 in the other. So remember, we check for greatest common factor of these 2 terms, so we can pull out an x squared, and we get x plus 6. And here we can pull out a negative 5, and again we get x plus 6. Now, because they both have an x plus 6, we can pull an x plus 6 out, and then remember in the other parentheses goes what's in front, x squared minus 5. Now, if these were not the same, then you would have to go back and use the synthetic division to try and find the solutions. So, either x plus 6 equals 0, or x squared minus 5 equals 0. Since they're both squared or less, we don't need to do the synthetic division. We can find the answers. So you can subtract 6 and get x equals negative 6, or you could have used the shortcut, the opposite of this, divided by that. So one answer is negative 6. And then x squared minus 5 equals 0, so x squared equals 5, and x equals plus or minus square root of 5. And so you can see on this we have 3 solutions, negative 6, and square root of 5, and negative square root of 5. And because the highest power is 3, that's what we should have gotten. Now, if you didn't recognize that you can factor this, you could have gone through. If we would have gone to going through the synthetic division, remember we take the factors of 30. Our factors of p are 1, 2 goes in, 3 goes in, 5, 6, 10, 15, and 30. And our factors of q are 1, So we could have gone through and done plus or minus 1, 2, 3, 5, 6, 10, 15, and 30. What are our possible numbers to try? We would have done the sign change. It's positive, positive, negative, so that's one sign change. Stays negative, so possible positive solutions would be 1. If we put in a negative x, remember if this was negative, 3 negatives is negative, 2 negatives is positive. Negative and a negative, that's 2, so that would be positive, and that would be negative. So we'd have 1, 2 sign changes. So our possible negative solutions would be 2 or 0. And then we can do the synthetic division. Now this is a case this is why when I have one positive, I would always try the positive numbers first. We know what it is already, so let's actually, I would try the positive numbers first, but since we already know the number is negative 6, that positive solution is that positive square root of 5, which we're not going to find in these. So this is a case where you plug them all in, and if you tried all the positive numbers, you'd never find one that works. So that'd be a case where you do a lot of work. One thing you can do on this, when you use the graphing, so one thing I'd like you to do, if you ever get you're trying and trying and trying, and you can't get an answer that works, what I would do is, if you go to the graphing calculator, and we go to y equals, we can just plug this equation in. So it's x cubed plus 6x squared minus 5x minus 30. And I graph that. Let's change this window. And I graph that. See, if I graph this, the positive one, I can see it's between 2 and 3, and we don't have any fractions to try. So I know it's an irrational solution. So that's something you can do if you're trying some and you're not getting anywhere. You can type it in the graphing calculator and kind of see where it crosses. So since we already know the answer is negative 6, I'm going to plug negative 6 in here. So we get 1, negative 6, 0, 0, negative 5, positive 30, 0. So we have that negative 6. So you would have found, you doing the synthetic, the negative 6 was an answer. And then remember, remainder, constant, first power, second power. So that's x squared minus 5. You set it equal to 0 just like we did here, and you get the plus or minus the square root of 5. So you can see if you can factor, you save yourself a lot of time, because this one, trying the positive numbers, I would have had a whole bunch that didn't work before I maybe went over the negatives, and there were a lot of numbers to try. So that would be that one. Our answer, again, we have 3 solutions. That would be the first one. Let's look at the second one. So that was number 11. We'll do number 12. So when I do this one, again, the first thing I should always check for is greatest common factor. In this case, 3 goes into all of those. So I can pull a 3 out, and I get x cubed minus 6x squared minus 3x plus 44. There's more than 3 terms. If I tried grouping this so I could pull an x squared out, and I get, so if I pulled an x squared out of that, I'd get x minus 6. I'm not going to get an x minus 6 out of this. So factoring helped us in that we removed a 3, so we got down to smaller numbers. And we can just forget about that 3 now. And now we take the factors of p, which are 1, 2, 4, 11, 22, and 44. For those of you that have trouble when you're finding these factors, you can just go 1, no, that's 44, 2, and 22, 4, and 11. You might end up with some space in between, but you get the factors by doing the combinations. It's just kind of helpful to have them in order. So again, we found that the factors of Q are 1. So our possibilities are plus or minus 1, 2, 4, 11, 22, and 44. So now we do the sign changes. We have one sign change, stays the same, changes. So positive solutions, there are either 2 or 0. Negative solutions, remember we do the sign change, we put a negative x in, 3 negatives is negative, 2 plus 1 is 3, that's negative, 1 plus 1 is 2 negative signs, so that's positive, and the constant stays the same, so we have one negative solution. So if I was doing this, because I have one negative solution, I would go ahead and try the negative numbers. So we have to do the synthetic division. 1, negative 6, negative 3, 44. And if I was to make a chart, again, I plug in 0. At 0, I know I'm at 44. So I'm a long way from there. So I would probably skip down a little ways. I wouldn't just start with 1 because I have a ways to go. So I'm going to try 4. So let's try 4. So we bring down the 1. 4 times 1 is 4. Negative 2. 4 times negative 2 is negative 8. Negative 11. Negative 44. So we have one solution. We know at 4, we are at 0. Now, here's the thing. How many numbers do I have left? 3. So I can write this as a quadratic. Constant, this is my remainder. Constant first power, second power. So this is x squared minus 2x minus 11. So you could try and factor this. Negative 11, negative 2, but the only factors of 11 are 1 and 11. They don't subtract to give us 2. So we're going to have to use the quadratic formula. So I'm going to go A is 1, B is negative 2, C is negative 11, and plug them in. So we've got 2 plus or minus negative 2 squared. Again, some of you rely on your calculators. Whenever you square a negative number, it's going to be positive. Minus 4 times 1 times negative 11, all over 2 times 1 is 2. So we get 4 plus 44 here. So we get 2 plus or minus the square root of 48. So like the last one that we did, we had the square root of 48, 16 times 3. So that becomes 2 plus or minus 4 square root of 3 over 2. Because 2 goes into all of those, we get 1 plus or minus 2 square root of 3. And then our other answer was 4. So again, it was, if you go back and look at this, it was to the third power that we started with. So we should have 3 solutions. In this case, we have one real solution, or one rational solution, and we have 2 irrational solutions. 1 plus 2 square root of 3, 1 minus 2 square root of 3. Remember we said we were going to have 2 positive solutions, or none? Well, we had 4. Then 1 plus 2 square root of 3 gives us another one, and then 1 minus 2 square root of 3 gave us a negative solution. So again, you can see the process. Just have to be careful as you go through and do it. Let's take a look at number 12. Or 13. We did 12. So again, first thing I check for is greatest common factor. I can pull a 2 out. X cubed minus 21x plus 20. If you don't pull out the greatest common factor, you'll still be able to get the right answer, but you just have to work with a lot bigger numbers, because remember, we'd have to do the factors of 40 over the factors of 2. Instead, now we're just doing the factors of 20 over the factors of 1, which is a lot easier to do. So our factors of p are 1 and 20, 2 and 10, 4 and 5. So we know, and then our factors of q are going to be 1, and so our answers are plus or minus 1, 2, 4, 5, 10, and 20. Since they're over 1, it's easy to come up with those. Now let's check our sign changes. So it goes positive to negative to positive, so that's one sign change. Then it goes to positive 2 sign changes. So our positive solutions are 2 or 0. Our negative solutions, if we plug a negative x in, 3 negatives is negative. Negative and a negative, that's 2 negatives. That's a positive and positive, so there's 1. And so now we're going to do synthetic division. We know that at 0, we are at 20. I'm going to try negatives because we should have one negative answer. Let's try, since at 0 we're at 20, let's try negative 2. Now remember, here's where you have to be careful. It skips from x cubed to x, so we skipped x squared, so I put a 0 in. Negative 21, 20. So we get 1, negative 2, negative 2. We get 4, negative 17, 34. We're at 54. So it's either crossed twice at negative 2, or it's on its hasn't come back down yet. So let's skip. Let's try negative 5 and see where that takes us. Again, I just write those down so I can kind of keep track of where it's crossing. 1, 0, excuse me, 1, negative 5. That would be 25, which gives us 4. Good, negative 20, so we get 0. So we have negative 5, we're at 0, so we found one of our answers. So now, again, as soon as we get down to 3 solutions, we can stop and we can look at the quadratic formula. Or we can try factoring it. Let's try factoring this, because this, remember, this is x squared minus 5x plus 4. 4 and negative 5, so that would be negative 4 and negative 1. And so x minus 4 and x minus 1. And so our solutions already had negative 5. X minus 4, so it would be positive 4. And x minus 1, so it would be positive 1. Remember we said we'd have 2 positive and 1 negative, and that's what we got. And so we found our zeros. So that one ended up where we could factor at the end and do it. Now, again, you could have used the quadratic formula, and you still would have gotten 4 and 1. The last one, x to the 4th minus 9x squared plus 20. So this one is really nice if you recognize we can factor it. When you have 3 terms, if that middle term is the power is half of this power, I would always check to see if I can factor that. So if I do the x method, I get 20 and negative 9. Well, that would be negative 5 and negative 4. That first term's a 1, so I don't need to build the box. We just have to remember, because this is x squared, normally if this was x, then these would both, it'd be x minus 5 and x minus 4. But because it is squared, it's going to be x squared minus 5 and x squared minus 4. Now, anytime it's a square, we should see if we can factor that further. We can't this one. This one we can. That's the difference of 2 squares, so that's x plus 2 and x minus 2. And this one we just, so we set it equal to 0. X squared equals 5 by moving the 5 over, so x equals plus or minus the square root of 5. And then we have So plus or minus the square root of 5, and then we have -2 and +2 for our 4 solutions. So it's really handy if you recognize that, because if you don't recognize that, then we have to go through the process of our factors of p are 1, 2, 4, 5, 10, and 20. Our factors of q are 1, positive solutions, we have 1, 2 sign changes, or 2 or 0, and negative. If I put it negative, that would be 4 negatives is positive, 2 plus 1 is 3, that's negative. So there would be 2 sign changes, so 2 or 0. And we'd have to then go through the process of the synthetic division and try those. You'd get those answers, it would just take a little bit more, a lot longer to do. So you have to be careful on these. It's complicated. I just want you to work on this the first night. We're going to have the next day in class to work on these further. So we're just doing one section for these 2 days. So good luck on this. Please follow the steps. Take your time. And it's going to be difficult. So you're just going to have to be patient, be ready to ask questions on the stuff you don't know how to do. Good luck.